Okay, so I was just going to explain this picture. This picture is just basically telling you, well, before I go to this picture, sorry, I'm going to go to this picture first. Alright, so this picture is just explaining all the ions in the periodic table and their charges. As you can tell, up to cesium, that's your group 1 ions, so you obviously know those, but these you have to know. Like these, like those are silver, that's one of the transition metals that's in the middle of the thing. So basically, basically these are not hard, because in AP Chem, we have to know them. So, like, it's not really much for me to explain to you what they are, because we have to know them, but you have, I think, you get, like, a box with their charges, so I'm not going to really go over it. So, basically, this isn't that hard. You just use your periodic table that has the charges on it. In AP Chem, we do not have the charges. We have to know every single element's charge. And we do not know the compound charges, like sulfate and stuff. We have to know that that's a 2- ion, a charge of 2-. So, you know that's not that hard, because you have a table that shows you that. Alright, I'm just going to explain what this picture is. This picture is just telling you, like, the shapes of it. So, CO2 is a linear, because it's like this. How many ions does O have? 6. So 1, 2, 3, 4. That should be it. This is 4 electrons. I just can't draw it because I just made them too close. Here, I'll erase it. Make it easier to see. If you did the Lewis structure of CO2, it would look okay, wait, let me just do it real quick, because I think I'm just mixing it all up myself. So, okay, I'm gonna admit, like, chemistry is just, my teacher does not explain it very well, just so you know. Alright, I know that there's 4 ions in carbon, as you can tell from looking at the periodic table. So you have O, which has 6. So you have 1, 2, 3, 4, 5, 6. So basically you can go like this. You can go, alright, and then that O has the same thing. But what you gotta do is you gotta take C, and I'm gonna put it down here just to make it easier. C has 4, 1. And then you have this O. Then you have 1, 2, 3, 4, 5, 6. And then let's erase this, because we don't need that anymore. 1, 2, 3, 4, 5, 6. Alright, let me just do it in different colors so you know which ones are the O's. Sorry if they're like kind of like spread out. Okay, so those are the O's. So what you gotta do is, since you have an extra electron here, you have to take it and move it to the middle. Since you have an electron here, you have to take it and move it to the middle to create a double bond. Now it looks like this. You moved this ion that was here to there, and you moved this ion that was on top of the C to there, which created an extra bond, which became a double bond. Now you do the same thing to this side, obviously, because you have an extra one here, and you have an extra one here, so you make a double bond, and it's going to look something like this. I don't know if you can see it, but it's a line. If you look, it's in the shape of a line, because you have O here, then you have C, and then you have O. That one's not hard to figure out the shape of it. Basically, you just have to look at it. Look up on the internet, like, the shapes of things, or whatever. But basically, to help you, This is my way of looking at it. Alright. You can also look at it this way. So, if you look at this first one, this one, you have MX2, right? So what does that mean? This isn't the Lewis structure since we already did it. Alright. So your M, I'm going to do it in green. Your M is your C. Your X's are your O's. I don't know why this is like taking, like this, God stinks, this, my thing. So that's a one way of looking at it. So if you have 3 O's, let's just pretend like that's a Lewis structure because it's not. If you have 3 O's, why won't it let me do it? Alright. That's your X's. And then your M is your C. And that's 1, so it's going to be a triangular. Like, you just have to work with it. And so, let's look at the next one. CH4, that one's easy too. Let's look at MX2E1. What does that mean? I think, wait a second. It's bent. Because you have basically the same thing as this, right? But this is how it looks. So let's look. S is 6, so you have, oops, sorry. 1, 2, 3, 4, 5, 6. Then you have your O's, which attach here, which has 6. So 1, 2, 3, 4, 5, 6. Then you have your O here. 1, 2. Pretend I'm putting it off to the side. 3 over there. 4, 5. I'm going to put it down here. Okay. Right? Well, as you can see, it's not linear. It's in the shape of this, which is bent. Okay. So that you just have to work with it. You just have to look at it. Make sure like you know what you're doing. It's not that hard once you get it. You just have to like look at the shape. And I would say look online. Look online at examples because honestly, you can't just get it by seeing seesaw. Like how are you supposed to know it's a seesaw? I don't even know. I'm just going to try to teach you the Lewis structures because I know that that's something that you need help with. Alright, let's try this one. What is this one? Oops, sorry. Alright. Okay. So this first one you have, I think it says BEF2. That's what you want? Alright. So BE is BE has, what group is that in? It's in group 2, so it has 2 electrons. So it is 1, 2, right? Now your F's are, F has, is in group 17, has 7. So 1, 2, 3, 5, 6, 7. Not that hard, so do the same thing to this side. I can't do it. Okay, like, I'm sorry, it's not letting me put that other extra one on top. Alright, there you go. Okay, so as you can see, it looks bent, right? But since there's only, 2 electrons of BE, and there's none here, you can switch this whole thing to move to the bottom. So it would look like this. Okay, I don't know why it doesn't let me put it on the bottom. It makes me actually very angry. So you're going to have this, which is a oh, sorry, not that. That's bent. I meant to write an L. It's a linear. Alright? So does that make sense? Alright, so